With the latest detection of gravitational waves, we have a new tool for looking at the universe. A new future lays ahead of us. For the first time, we have seen two black holes merging together, forming a single black hole and ringing down in its final state.
We're looking at the vibrations in space and time itself. It's absolutely unique.
Oh, this is pure gold.
We have seen really the merger of black holes. Who could believe that?
People should realize that we have been looking at the stars as mankind for thousands of years. And now, for the first time in history, we are able to look in an entirely new way at the universe.
Nikhef, the Institute for Subatomic Physics in the Netherlands, is a big player in the hunt for gravitational waves. Chris van den Broeck supervises the data analysis in the LIGO-Virgo collaboration.
So this is what the signal looks like, but this is just the signal as a function of time. The data will look more like this, and you see kind of a chirp in here. This is time, this is frequency, and you see a feature in here. What you do is you look at the behavior of your signal, and if it really comes from a binary black hole merger, then what you should see is a banana shape like this. That is, originally the frequency was rather low, but then in a very short amount of time, the frequency became very high, and then it stops. Because a single black hole has formed, and it's settled down, and no more gravitational wave emission comes out.
The first detection already tells us new things. That is a binary black hole, so two black holes merging, which we thought would exist, but we didn't know. And the other thing is they're much more massive than we see black holes in our galaxy. So we can immediately learn that these objects were formed in an environment that's quite different from our own galaxy.
You can probe quite a lot of very intriguing questions. So you can map the part of the universe that you cannot see right now. So everything that we know about the universe comes from light. And gravitational waves, you can see them from objects such as black holes, which do not emit light.
Einstein predicted 100 years ago, almost exactly, that gravitational waves exist, but he never believed that humans would be able to detect them.
We can detect gravitational waves because we are able to build cutting-edge instruments. Advanced technology that made it possible to detect and analyze the gravitational signals. A lot of this has been done right here at Nikhef.
The power is huge of Nikhef. It's a fantastic institute because we do a lot of things. We are searching for fundamental interactions and fundamental building blocks of our universe. And we do that by both a theoretical department, theorize about how our universe looks like, but also very practically by making a lot of instrumentation.
These instruments are so incredibly specialized. They are so far away from what anybody makes or can buy that we have to develop all this ourselves.
What we have built here didn't exist before, so it is really top of the bill, something new. It's not something you buy from the shelf. In the computing, for example, we have so much data that we have to process in order to understand all the data that's coming from this Virgo, but also from the LHC. That new techniques are being developed. We're looking at boundaries. Boundaries of science, boundaries of technology. And here you have a clear example with a new boundary was pushed and thereby being sensitive to something we have never seen before.
In Italy, the Virgo detector is being upgraded to become more sensitive. The detection of gravitational waves is a worldwide collaboration of scientists.
We have 19 laboratories from 5 countries, Italy and France, which were the founders of Virgo, the Netherlands with Nikhef, Hungary and Poland.
Many of the optical instruments that will increase Virgo sensitivity are provided by and built at Nikhef in Amsterdam.
I think the main driver of people here is scientific curiosity, and I think that's a very focusing force. People really want to answer new questions in science. Oh, no. No, come on. No. This is really the beginning of a much longer journey.
It's the first step, day one of a new chapter.
For that we may need a huge infrastructure, and we're dreaming sometimes of putting that in the south of the Netherlands, a huge Einstein telescope there.
That would be, of course, really, really spectacular and an opportunity, if at all possible, we should not miss.
Or in space looking for gravitational waves.
With that, you can make the arms of the detector much bigger, and with that, you can observe completely different objects, supermassive black holes, white dwarf binaries in our galaxy, maybe signals even from the very early universe, where just a fraction of a second after the Big Bang.
So I think the future for us is extremely bright.